In this lesson, I want to talk to you about the second color theory of light that we talk about in grade 10 science, and that's called the subtractive color theory of light. You'll recall that the additive theory deals with mixing different kinds of light together to create new colors. This new theory that we're going to talk about here today kind of deals with the absorption of some colors and the reflection of others. And for example, you can see the shirt I'm wearing right now, which is red, a Canadian t-shirt, is red because it reflects red light, believe it or not. And it would absorb other colors of light. So when you look at my diagram here, you can see red light. It actually would absorb other wavelengths like blue, green, and cyan. So kind of interesting. If you look at the black in the middle, believe it or not, black objects don't reflect any colors of light. They absorb everything. So this theory is a little more applied in terms of what we wear in the clothing industry, to be honest. So let's look at it. Well, colored objects absorb different colors or wavelengths of light. So it does depend on what color you're wearing in terms of what wavelengths or colors it would absorb versus those that it would reflect. Absorbed colors are subtracted from reflected light seen by the eye, and we'll talk about this in a second here. Black objects, like I've already said, absorb all colors of light. They don't reflect anything. On the other hand, if you wear a white t-shirt, it kind of makes sense. If you're shining light on a white t-shirt, it appears white because it reflects all colors of light, and you know that white light is composed of all the different colors in the spectrum, or Roy G. Biv. So that is a quick look at subtractive color theory. Now, I just want to go through an example here to show you what we're really talking about. So here we go. These are your primary subtractive colors. So magenta is one of the primary colors on the outside. Yellow is another, and cyan is the third. So those, my friends, are the primary colors of the subtractive color theory. When you look at blue, red, and green, those are the secondary colors according to the subtractive color mixing theory. How does it work? Well, here are three diagrams, and we're going to take a look at them in turn. The first thing we're going to understand here is if a color is absorbed, it will not be seen by your eye. Hence the reason why my shirt is red. You can see red because it's reflected. That's the only color that you see. There are certain other colors that are absorbed that you don't see. So truthfully, the color of the shirt is really dependent on the type of light we're shining on it, as opposed to the fact that it's just a red shirt. If you've ever been to a neon dance where they shine special lights on people, or at bowling alleys, I know in Simcoe there might be some of that going on. You look down at yourself and you seem to be glowing, or your shirt looks a different color. Again, it all depends on the light that's shining on it. So the left picture shows a cyan object, which is kind of a turquoise color. And if we shine white light on a cyan object, which is a mixture of red, green, and blue, we only get blue and green reflected. So those are the two that you would see. The red light in this case would be absorbed. If you look at a magenta object, on the other hand, which is the next primary color we're talking about here, and we shine white light on it, which is a mixture of red, green, and blue, you can see that red and blue get reflected, but the green light gets absorbed. And finally, if you look at the third primary color according to the subtractive color theory, which is yellow, if you shine white light on a yellow object, which is red, green, and blue, the red and green get reflected, but the blue gets absorbed. So that is a quick look at subtractive color theory. The most important concept is to realize that when you look at a t-shirt that somebody's wearing, that's the wavelength that's being reflected. It's as simple as that. Now, let's look at the two theories together, and I hope you see some direct comparisons. First of all, the primary and secondary colors of light for the subtractive theory that we just did here on the right are opposite to the colors of the additive theory. So you can see that the red, green, and blue that we learned about previously in the additive theory, which are the primary colors of that theory, are secondary colors for the subtractive theory, and vice versa. For the additive theory, the yellow, the magenta, and the cyan are secondary colors, and you'll see that in the subtractive theory, they're primary colors. So that's a quick look at the subtractive and additive color theories. And I know if you are a hockey fan, hockey is starting up, and like some of you, maybe you're burdened by the fact that the Maple Leafs, they're playing in Canada, and yeah, I've got my shirt on. It is orange, and of course, orange light. This shirt is orange because that's the wavelength of light that it reflects. I did my best, whether the Leafs win or lose. This shirt is orange.